Okay, I'm going to be going through how to fix these segmentations on 3D Slicer, and how to then output that file to something that's actually Numpy friendly. So the first thing you're going to do is you're going to open 3D Slicer, get your data. Everyone's going to be responsible for their own files, and then you're going to open up one of your segmentations. So in this case, we'll just do 402, and then we'll look at segmentation 402. We're going to open this up, and the first thing to make sure to do is, so the MRI is going to open as a volume. Great. And we want to open the segmentation as a segmentation. Okay. So the first thing you see, and some of you may have noticed this, is that the segmentation over here, if you try to load it back in, it doesn't appear anywhere near the actual brain. And the reason for this is that so for some reason it's saving the coordinates backwards and then reloading them in backwards. Remember how there's that coordinate choice that we had to make? For some reason that didn't save out correctly. I don't know why. If for some reason you open it up and it does just sit perfectly over where you expect it to, then don't worry about this next step. But okay, so the first thing we need to do is we need to fix this. So we're going to go up to Transforms, and it turns out we just need to flip it. We just basically need to rotate it 90 degrees. And so the easiest way to do that, you can do it two ways. Actually, probably the easiest way to do that is to just, so you can either do -1, -1, or you can just drag this slider all the way over. Click on the segmentation, transform it over, it rotates, and bam, there it is, right on our brain, right where we want it. You'll notice that the fidelity isn't like perfect. The reason for this, of course, is that so it has transformed it into this beautiful surface file, but in doing that, it loses some information. We also probably made some little cuts that weren't perfect, but that's fine. I've showed the data to Z Imaging; they seem happy with it. Okay, so go do that. And then the next step is we need to go to Segment Editor. We need to click on our segment here, and we need to make sure that we have selected the correct master volume. So we need to make sure that it's referencing the MRI to get its volume. Okay, so now the next step is we need to use some Python. So we'll open up this Python editor. And so it turns out that there's a really robust Python editor in 3D Slicer, and it interacts with Python fairly nicely. So I gave you the files here for what you have to do, but let's walk through it. So the first thing, because we are going to have to change some commands. So the first thing that we're going to need to do actually is if we go back to data, we're going to need to look at these file names. So let's go over to all nodes, and you can see I actually have a bunch of crap here. It's really, really useful to clean out it's really, really useful to go up to and do File, Close Scene every time you're done with one of these. But anyway, so we're going to need the names of these nodes here. So first, we're going to call MRI file our MRI file, and usually it will just be whatever it's normally saved as. For me, I've loaded this in a couple of times, so it'll be we'll have a -2 there. Then we're going to call segmentation name the segmentation name. In this case, I think that is actually correct. It just came as what it came as. And then we're going to specify the output path. So for me, the output path is going to be in OneDrive in my Jupyter Notebooks. It may be someplace else for you. Okay, so then we're going to run some code. You don't really have to know what this does, but I'll explain it if you're interested. So this whole thing is scriptable. So the first thing is we're going to use slicer to get our node, which has the name of the MRI file. If you get an error on any of these lines, so if you get an error on this line, it just means your MRI file is wrong. Then we're going to get the segment. So again, if you get an error on this file, it just means that the name of your segment's wrong, and you should just copy and paste it. Then we're going to create a new node called label map volume node, and we're going to construct it with a certain class. Boom, there we go. This is going to store the pixel data from this segment in just a moment. And then we're going to store the pixel data from the segment into label map node, and we're going to do it in the coordinates volume node. Great, and this should return true if everything's worked. And if it returns false, then something's gone wrong in the previous steps. Okay, so great. So now we're going to take everything from volume node and store that in DICOM data. So this is going to be a pixel representation of this nice cleaned up MRI here. And then we're going to take everything from the label volume node and store it in mask. And then it's important to just check here that the shape of mask is in fact 176.208.176. If it's not, there's a good chance that you didn't do that step. If you remember when I went back and when I went to the segment editor and I clicked on the segment geometry box and fixed it to inherit its geometry from the MRI file, there's a good chance that you just didn't do that, or that for some reason you didn't rotate it. Okay, so at this point, you can actually, if you want, so this is a full Python console, so if you want, you can dump this as a NumPy array and whatnot. But we have all of our pixel data, so we're going to create a new file which is just MRI file up to 12. You could use, I want you to do up to 12 because you'll notice then it's just the first little bit of the file, which is maybe going to be a little bit easier to deal with. And then we're going to save the DICOM data out in a compressed NumPy format. So output path plus file plus .npz for the DICOM data. And oh, and I apologize. So of course, in the document that I sent on, there's another step there that I did not include, which is to do from NumPy import as array and saves compressed. So that'll actually allow us to save out that compressed. And then finally, we'll save the mask out as a compressed file. And so that should be it. And in theory, so again, you should have the mask is going to be your segment file, and that should be the same shape as the DICOM data file. So it should be the same shape as the MRI file. And so then I also have a little more information on how to bring it in, but then loading these things into NumPy is very straightforward. And you'll see that it loads in this nice crisp picture, not the sort of horrible MRI that we've been dealing with, the sort of horrible unprocessed MRI that we've been dealing with so far. Okay, so hopefully that's explanatory. So then, for your next one, you just go back to, your data, delete everything here, and start again. And then finally, so if and as you do more segmentations, I would encourage you to save them out as the STL file, but also after you do the segmentation, you can just directly export it here like we did. At the end of the day, I think that our goal is going to be to create a bunch of these NumPy files, and then that's what we're gonna do our classification on. So in particular, once we have finished this, then you guys will actually have files that you can pull into Numpy and that you can start training on. Okay. Let me know if you have any questions.